Okay, so we are going to be going over 6E. 6E is referring to learning to understand the transformations of a cubic function. So before we get started, we need to understand what is the basic cubic function. So that is f of x is equal to x to the power of 3. So the first thing we need to be thinking about is we've talked a lot about dilation in the past, in the previous chapter. So dilation is that a value out the front of x to the power of 3. So we know that if the a is bigger than 1, what's going to happen is it's affecting our y value. So it's being pushed and stretched away from the x-axis. So pushed up. Or if it is less than 1 and greater than 0, then straight away that means that it is going to be compressed towards the x-axis. So that's the main thing that is focusing on. Now, in terms of our domain and range, if there is no restrictions, it is implied that it's for all real numbers. You'll notice that there's an inflection point that I'll be going to that you can see at the moment is starting at the origin. So this is where in our original form we've got a h and k. Depending on what those values are will depend on if there is any horizontal shift or vertical shift. So as I said just then, the point of inflection is at 0, 0. So for a vertical shift, it's where we are either plusing 2 or minusing a number on the outside. So right here, because I've got +2, it shifts my point of inflection up by 2 points to get to 0 and 2. Likewise, if I've got a horizontal shift, so I've got x plus 1 in the brackets. Likewise, when we've done a quadratic or any of our other functions, it means that there is a horizontal shift to the left by 1 unit, which is what we're seeing here. So this inflection point is when the gradient is 0. So let's look at putting both of them together. So first, it says sketch the graph of the function f of x is equal to x plus 1 in brackets to the power of 3 minus 2. So the first thing we need to identify the point of inflection. So that means I can see that it's got a horizontal shift of 1 to the left and a vertical shift down by 2. So that gives us -1 and -2. Based on that, we then need to be able to look at is there any x-intercepts. So to calculate an x-intercept, we are going to make y equals 0, and we're then just going to solve. So that means I will add 2 to the other side. I am then going to cube root. So cube root of 2 is equal to x plus 1. Now, you'll notice with the cube root, I haven't put in any value there. So, and that's because it will only give us a positive answer here. And then finally, I need to take 1 away. The next step is we need to calculate our y-intercept. So again, we're going to make x equals 0. So 0 plus 1 is 1, 1 cubed is 1, 1 take away 2 is -1. And now I'm able to graph this. On the class pad, I'll get it back up. If I wanted to graph it, all I needed to do in menu, go to graph and tables. I can then type in what I have. So I've got x plus 1 in brackets to the power of 3 take away 2. So first I've clicked it so we can see what's happening. The next part that I can do is I can go to Analyst, GSolve, and this is where I can find all the points I need. Inflection point. It tells me it's -1 and -2, which is what I just said. Again, in Analyst, GSolve, I can go down to root, and it will tell me my root is 0.2599. And I can check that by typing this onto the calculator. Likewise, if I wanted to find my y-intercept, I click on y-intercept and it will tell me when x is 0, y is -1, which is exactly what I just got. Okay, next one is sketch the graph of the function f of x is equal to -2 x minus 3 in brackets to the power of 3 plus 1. Okay, so the first thing that we are going to do is identify all the main points. So let's identify the point of inflection. So straight away here, I've got a horizontal shift of 3 and 3 to the right, and it's going up by 1. So that's the first part that we need to work out. What is that inflection point? Then from here, we're going to do the same thing. We're going to calculate the x-intercept. So to calculate the x-intercept, we're making y equals 0. So that's where now we are just going to work backwards. That means I will take away 1. I will then divide both sides by -2. So to get a half is equal to x minus 3 in brackets to the power of 3. I cube root a half, and then I plus 3 to get x by itself. Likewise, to calculate the y-intercept, first thing I do is make x equals 0. So 0 take away 3 is -3. -3 to the power of 3 times -2 is 54. So I got 54 plus 1 equals, oops, 54 plus 1 equals 55. So there's a small error on here, so I'll just change that, 55. Okay, so based on that, I then can go to the next part, and in that intercept there should say 55. So make sure every single time you label your inflection point, any roots, and your y-intercepts. Again, I'll just do this one on the class pad. I won't do them all like this, just so we get a sense of understanding how to check. So if you can't remember, we go menu, graph and table, and then I type in my equation, -2 x minus 3 to the power of 3 plus 1. I then click and graph that, and then I can check everything. So I can go gsolve, y-intercept, and it tells me at 55. I can go gsolve, inflection point, which is 3 and 1. And then I can go analyst, gsolve, and root, and it tells me it is at 3.7937 for x. Okay, let's have a go at the next question, and then we're going to move on. So sketch the graph of the function f of x is equal to x plus 4 in brackets cubed take away 3. So the first thing we're going to do is identify the point of inflection. So that means we know we have gone 4 units in the negative direction of the x-axis, and we've gone 3 units down. So that gives me -4 and -3 as my inflection point. I then need to do step 2, which is find x-intercept. X-intercept means I need y equals 0. So if y is 0, all I need to do is substitute that into my equation and get x by itself. So I plus 3, I cube root, and then I have to take away 4 to get x by itself. To work out the y-intercept, I need to make x equals 0. So same thing, but this time I've got 0 plus 4 is 4. 4 cubed is 64. And 64 take away 3 is 61. And then I'm just graphing that. Make sure you label each of these crucial points as a coordinate on your graph. Now, we are going to look at inverse functions in regards to this. So in this, we have an inverse function here because it's a one-to-one graph. So if I go back here for a minute, if I draw a line it's a horizontal line is only going to cross over my graph at one point. It doesn't matter where I pick. There's only one point that it's going to cross. So that's why we know it's one-to-one. So that means there is an inverse. And to work out inverse, as we've done before, we are just going to switch the x and y values around. So let's have a look at that. Now, before I do, just make sure that if we're switching them around, we need to make sure that we know that our range and our domain are going to be switching. So straight away here, we can see at the moment our range is all real numbers. Our domain here is all real numbers. So it's not really affecting it at all in terms of that regards. But what we can see is the inverse. If we do an imaginary line, and this line is not accurate, apologies. It is so that it is a line at y equals x. So we can see that if we do a line there, this is showing you that relationship of that mirror. Now it's not working on there. I'm just going to quickly get up Desmos to go over this and show you a bit better. Okay, so if I type in y equals x, this is my mirror line. Now, if I'm just going to look at what I've got here, which is y equals x to the power 3. So that's the graph we have over here. And we've just said that our inverse is going to be y is equal to x to the power of 1 over 3. So what we can see is there's that relationship with this mirror line. Now, this mirror line, it means that our inverse and our function is always going to meet on that mirror. So we can see it's meeting at 1 and 1, 0 and 0, and -1 and -3. So we need to make sure we are writing it as a rule. So our inverse is going to be the function, the domain is all real numbers, is graph with all real numbers of f of x is equal to x to the power of 1/3. Now, if I wanted to find the inverse function of this, the first thing I'm going to do is swap the input and outputs. So instead of saying y equals 3, x minus 2 in brackets to the power of 3, take away 5, I'm just going to switch my x and y around. Next, I'm just going to rearrange to get y to be the subject. So that means I will add 5. I will then divide by 3, and then I will cube root, and then finally plus 2. So this gives me my inverse. If I'm going to write it in function notation, the inverse of f with a domain of all real numbers is graphed with all real numbers. The inverse of f of x is equal to cube root 5 plus x over 3 plus 2.